Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss helium neon laser. Let's begin. Helium neon laser is the first successful gaseous laser, and it was built by three scientists, one named Aljavan, another W. Binet, and D. Harriot in the year of 1961. The construction of helium neon laser. Helium neon laser consists of a long discharge tube of length 50 centimeter and diameter 1 centimeter. A long discharge tube, its length around 50 centimeter and its diameter around 1 centimeter. The tube contains a mixture of 10 parts of helium and 1 parts of neon. 10 parts of helium, 1 parts of neon at a pressure about 1 millimeter Sg. In that of tube, it contains helium plus neon. Helium and neon at a ratio of 10:1. Helium 10 parts, whereas neon 1 part. The gas mixture of helium and neon forms a lasing medium, and it is enclosed between a set of mirrors that forming resonant cavity. One of the mirror is completely reflecting and other one is partially reflecting, so that the laser beam may come out. Two mirrors, one mirror is totally reflecting, another one is partially reflecting, partially reflecting because the laser beam may come out from that partially reflecting mirror. Since it is partially reflecting, so some of the beam is reflected and some are transmitted. So, the laser beam is transmitted by using that partially reflecting mirror. We obtain laser beam. A stationary glow discharge is excited in the gas by applying a few kilovolt of DC. The electric discharge source. In order to supply the pumping, and the pumping by the method of electrical pumping. The faces of the tube are inclined at restoration angle to get plane polarized light. That is the discharge tube, and these two faces are inclined at an angle of restoration angle restors into, in order to get a plane polarized light, we use Brester's window. In optics, in detail we discuss about what is Brester's angle. Basically, here Brester's window is used in order to achieve that polarized light. This is the overall construction of helium neon laser. Let me elaborate it. A long discharge tube having length 50 centimeter, diameter 1 centimeter. It is filled with helium plus neon, helium around 10 parts, whereas neon around 1 parts. And these two faces used as Brester's window. Two plane mirrors, one is totally reflecting, another one is partially reflecting, in order to achieve the laser beams and the electric discharge source. Next, what be the applications, what is the working process of that helium neon laser? Working, and the working of helium neon laser can easily explained by using the energy level diagram. First, when electric discharge takes place in the gas mixture, electric discharge to that of gas mixture, some of the atoms of the mixture get ionized and the electrons get accelerated in that of discharge tube, and these accelerated electrons collide with helium atoms and excite them from level F1 to level F2 and F3. Let I draw it. Since it has two atom, one is helium, another one is neon. For helium, this is for helium, the ground state F1, and its excited states as F2 and F3. Same for neon atom. Its energy levels E1, E2, E4, E6, reach E5, E3. First point, these accelerated electrons collide with helium atoms and excited them from F1 to level F2 and F3. For helium atom, it is excited to F2 and F3. That is excitation by collision with electrons. Excitation by collision with electrons. Next point, the levels F2 and F3 happen to be metastable states. Due to that metastable states, thus helium atoms excited to these levels spend a sufficient long time before getting de-excited. F2 and F3 reach the metastable state, that is metastable state, metastable state, metastable state. Due to that metastable state, the electrons or the excited atoms required a much more time in order to further de-excitation. Next point, some of the excited states of neon correspond almost the same energy as the energy of excited states F2 and F3 of helium. Look at that energy level diagram. That is the energy level of helium, its excited states F2 and F3. That energy level is equivalent to the energy level of neon atoms as E4 and E6. Therefore, when helium atoms in levels F2 and F3 collide with neon atoms in the ground level E1 and energy exchange takes place. Consequently, neon atoms get excited to the levels E4 and E6 and the helium atoms get de-excited to the ground state F1. Since helium atoms have a longer lifetime in excited states F2 and F3, thus this process of energy transfer has high probability. Look here. Now, for neon, the energy level E4 and E6 is very equivalent to that of energy level F2 and F3. Therefore, due to the collision, that energy is transferred to the ground state atom of that of neon. That energy and the energy transfer by collision, energy transfer by collision. Then the de-excitation occurred in case of helium. The process of energy transfer has high probability, and the helium atoms have a longer lifetime in that of excited states F2 and F3. Next point, due to that scenario, the electric discharge through the gas mixture continuously populates the neon excited levels E4 and E6. This creates a state of population inversion between the levels E4 or E6 and lower energy levels E5 and E3. Now, it has the metastable states E5 and E3, E5 in between E6 and E4, E3 in between E4 and E2. Also there will be a metastable state, but we do not consider that one. Now, in E5 and E3, due to that of metastable state, it achieved the phenomenon of population inversion. Now, the transition takes place from level E6 to E5 with laser wavelength 3.39 micrometer. Now, the transition from E6 to E5. The transition from E6 to E5, it has a wavelength of 3.39 micrometer. Then from the level E6 to E3 with a laser wavelength 6328 angstrom, E6 to E3. It has a wavelength 6328 angstrom. Next, E4 to E3. E4 to E3, E4 to E3. That is 1.15 micrometer, 1.15 micrometer, and the wavelength .39 micrometer and 1.15 micrometer. The wavelength 3.39 micrometer and 1.15 micrometer correspond to infrared region. These two, that is for infrared, 1.15, that is for infrared region, which is not visible spectrum, but 6328 angstrom corresponds to red light, that is for red light. it is under that of visible spectrum. So, at that of situation we obtain the laser light. Next point, mirrors of optical resonators are so designed to have low reflectivity for wavelength 3.39 micrometer and 1.15 micrometer. For that region we use such kind of mirrors, one totally reflecting, another one is partially reflecting, in order to pass this two particular wavelength of 1.39 micrometer and 1.15 micrometer. Thus, photons with these wavelength will be eliminated. Therefore, the photons of wavelength 6328 angstrom will move back and forth in that of optical resonator system, and thus laser of wavelength 6328 angstrom emerged through partially reflecting mirror. Now, 6328 angstrom, which is red light, that is under that of visible spectrum. Therefore, that wavelength of photon now emerged at that of partially reflecting mirror in order to obtain that laser beam. Next point, now that excited neon atoms de-excite from that of energy level E3 to E2 by spontaneous emission. Next, from E3 to E2, that is the process of spontaneous emission, and it is around 0.6 micrometer wavelength. Spontaneous emission, and it emits a photon of wavelength 0.6 micrometer. As the level E2 is also a metastable state, the energy level E2 is a metastable state, there is a probability of excitation of neon atoms from E2 to E3, that leading to the quenching of population inversion. So, what is quenching? Quenching is a process in order to achieve its mechanical property by rapidly cooling that particular substance is known as quenching. Now, to eliminate that quenching, the narrow discharge tube is used, because in neon atoms de-excited to that of level E1 from E2 through that of collisions with the walls of that of tube. Therefore, we use a narrow discharge tube in order to destroy that quenching. Finally, the output of helium neon laser is continuous and lies in between that of power 1 microwatt to 150 microwatt for the input of 5 to 10 watt. Now, it is from E2 to E1 transition due to de-excitation by collision, and finally, at this region 6328 angstrom we obtain the laser beam. The laser beam is obtained, it is the red light wavelength. And it is a 4-level laser system. For helium, it is stimulated absorption, then population inversion due to that of metastable state, and spontaneous emission, then its de-excitation by the collision. So, it is a 4-level process, 1, 2, 3 and 4. Next, the application of helium neon laser. Helium neon laser, that is a gaseous laser, first successful gaseous laser, is used for research, spectroscopy, holography in order to create the 3D painting is known as holography. Next, communication. In case of communication, telecommunication or radio wave communication, we use helium neon laser. Then weaponry, weaponry in the sense basically laser guns or any kind of weapons used by the technology of helium neon. So, here with the help of this video lecture we understand the concept of helium neon laser, its construction, working, these are the points on working, and these points are easily understood by taking the energy level diagrams of both for helium as well as neon. Overall, that is the working process of helium neon laser, and it is a 4 level laser system. And finally, the application of helium neon laser. So, with this useful and informative notes, let me wind up this session. Thank you.